Okay, this is the second part of Day 7 notes, and our first problem here is very much like the last one we did. It tells us that we want to find the other trig functions if we know what cotangent x is. Well, first we have to remember, what is cotangent? Well, cotangent is the opposite of tangent, so it is adjacent over opposite. So looking at our triangle, this side is the adjacent, so this is 4, and this side here is the opposite, so this is 3. But how do we find the hypotenuse? Well, I hope you remember that we use Pythagorean theorem. A squared plus b squared equals c squared. So that's 3 squared is 9, 4 squared is 16. That gives us 25. So C is 5. From there, we just remember each one of our trig ratios. Sine is opposite over hypotenuse, so that's 3 over 5. Cosine is adjacent over hypotenuse, so that's 4 over 5. And then tangent is opposite over adjacent, so that's 3 over 4. Then these are each the inverse of this one. So cosecant is hypotenuse over opposite. Secant is hypotenuse over adjacent. And cotangent is adjacent over opposite. That's the one we had right here. Now I would like you to take a minute and look at the patterns you see here in these numbers. What you should notice is these, if I look this way, going from this one to that one, those are just reciprocals. That's how we defined it. But also notice that the numerators of these two give me that one. The denominators of these two are the opposite of this one. These patterns that you see here are always going to be the same every time, no matter what triangle you have. Okay, the one remaining thing that we have is, what if I have two sides and I need the angle? Well, this is another thing that trig is good for, and you actually saw it on the videos from last time, but we'll go over some problems again here. And these are still using our basic trig functions. So the first thing we should always do is label the sides they gave us. This side is the hypotenuse, and this side is opposite of this angle. Then we have to ask ourselves, which one of our trig functions has hypotenuse and opposite? Well, that would either be sine or cosecant. We're going to choose to use sine, and I'm going to use an x here for this angle. And I'm going to choose to use sine instead of cosecant because sine is on my calculator and my calculator doesn't do cosecant. So then I'm just going to fill in my opposite and my hypotenuse here from my triangle. So I have sine of x equals opposite, which is 34, over hypotenuse, which is 55. And then I'm going to use an inverse sine function. This is a button you can find right on your calculator. I'll get my calculator out. Here's my sine button, and right above it is the inverse sine button. Cosine, inverse cosine, tangent, inverse tangent. Notice I'm not using any other buttons. I'm still just using these three right here. So what I do to get rid of the sine is I use inverse sine. And what I'm really doing is this. I'm really taking the inverse sine of this side, and I'm taking the inverse sine of this side. And remember, I can do anything as long as I do it on both sides of the equation. This side over here, sine and inverse sine are reciprocal functions. They're inverse functions. So the inverse sine and the sine cancel out and just leave me with x. And on this side, I'm left with this. This part right here I can put into my calculator. So what I'm going to type in, okay, the first thing I want to do on my calculator is I want to look at the mode. And under the mode, there's two parts here, radians and degrees. For now, we're going to go ahead and pick to put our calculator in degrees. And actually later on our worksheet, the next thing we're going to do is talk about how to convert between radians and degrees. But for this part, we're just going to answer these in degrees to simplify it. So once I have it in degrees, now I can just enter this in my calculator the way it is. I push my inverse sine button by doing second and sine, and then I type in 34 divided by 55. I don't even have to close the parentheses. When I hit enter, it tells me that x, that angle right there, is 38 degrees. And we're going to go ahead and put one decimal place on there, 38.2 degrees. Okay, let's do the next problem. Do you remember the steps? First step, write down on your triangle what these sides are. Well, if that's the angle I'm looking at, this is the hypotenuse, and this is the adjacent. And then I think which one from SOHCAHTOA has adjacent and hypotenuse? Well, that's cosine. And cosine is adjacent over hypotenuse, so that's 52 over 56. Now to get this cosine out of x, I have to do the inverse operation. I have to take the inverse cosine of both sides. And what I get on this side, I'm just left with x. And on this side, I've got cosine inverse of 52 over 56. Now I just go to my calculator with that. I don't have to do the mode every time. Once I've put the mode on degrees, it'll stay on degrees until someone changes it. So I'm going to go in and type this on my calculator. Second cosine, 52 divided by 56, enter, and there it is, 21.8 degrees. And my last problem here. Here's my angle. This is the adjacent. This is the opposite. Opposite and adjacent, that's tangent. Tangent x equals opposite over adjacent. Take the inverse function, plug that in my calculator. Second tan of 8 divided by 20 tells me my angle is 21.8.